Today's learning target is I can display and analyze data using a line plot. In today's lesson, we're going to be talking about line plots. Now, we can see right here that we have an example of a line plot. There are a couple of things that we're going to find when we deal with line plots. One is a title. Obviously, that's important because we need to know what it is that we're looking at. So in this case, we can see that we're looking at the weights of dogs. Okay, now line plots always have what's called a scale. The scale is the number that starts your line plot and the number that ends your line plot. So that's your scale. So the scale for this line plot is from 10 to 30. And line plots also have data, and data is the information in the line plot. So any information, that's data. So the data in this line plot shows me the weights of different dogs. So I can see that right here there's two X's at what's number 12. So that means there are two dogs that weigh 12 pounds. And really this line plot should have labeled what these numbers are too, just saying in pounds. Here I can see that the most dogs that they checked weighed 15 pounds because there's 4 of them here. And then one dog weighs 16 pounds here. Here's a group of 3 dogs that weighed 25 pounds. And the heaviest dogs were over here at 28 pounds, and there were 2 dogs that weighed 28 pounds. So let's take a look at how we make a line plot. So you can see over here I've gathered some data. That's our information here. And this data you can see that I've gathered is the points scored by the 1998 Minnesota Vikings. Now you might ask yourself, why would I look at that? Well, if you ask any Viking fan, and this is a painful subject for me, but the 1998 Vikings were a team that was supposed to make it to the Super Bowl, and they never did. They had this amazing offense that scored a ton of points, but they lost in the playoffs. It's a little painful for me. If you have a parent or know someone who likes the Vikings, ask them about the 1998 Vikings, and you'll probably see a little bit of pain on their face as well. Now the first thing I need to do when making a line plot is I have to determine my scale. Remember, my scale is going to be the lowest and the highest number. So when I look at my data here, I see there's a 24 is going to be my lowest number, and I see that 50 is going to be my highest number. So when I'm doing this, I'm going to go, and I think I'll go by 5s when I do this. So figuring this is going to be 50 here, and if I start at 5s, I'm going to have to start at 20 right here. Now from here what I like to do is put a line in the middle, and in between, halfway between 20 and 50 would be 35 because there's 15 on each side there. And now I can just place in, so this would be like 25, that'd be like 30, 35, then I've got 40, 45, and 50. Then what I do is I just fill out the rest of the lines like I did there. So now we can see I have all my numbers from 20 to 50. Now I'm going to place an X for each data point that I have. So I can see the 31 here. I'm just going to cross that out. I'm going to put an X on 31. Here's a 38. So 38 would go right there. 29 is going to go right there. 31. Okay, there's another 31, so I put that on top of 30. So now I've placed all of my data in here. You can notice I crossed it out as I did it, and it's all right in here. The last thing I want to do is make sure I add a title. So right here would be what a good line plot would look like. When we have a line plot like this, we can begin to analyze the data that we see in it. So for example, I can see that the 1998 Minnesota Vikings, the most points they scored in one game was 50. I can also see 31 was the point total that they scored the most often. Okay, I can see the least number of points they scored was 24 points, and they scored that twice. I can also find what's called the range, and the range is the difference between the biggest number and the smallest number that we have. So in this case, the range would be 50 minus 24, which would equal 26. So my range of my data in this is 26. The last thing we're going to take a look at today are outliers and clusters. So we can see that this line graph here are books that were read in the summer by 6th graders at Taylor Middle School. Now, outliers are any data pieces that lie outside of where most of the other data is. So I can see right here, this one, somebody read 21 books over the summer. Okay, we can see that's quite a ways away from our other data here. Okay, so this would be considered an outlier right there. Okay, a cluster, when we see the word cluster, that's like a grouping of data that's pretty close together. So right here, this would be a cluster. So that data is all pretty closely packed together. So those are outliers and clusters.